Okay, good morning. Thank you everyone for joining us today. There's over 250 of you who've registered for this. So it's pretty exciting for us. We're glad that there's so much interest in the cloud that we have. And hopefully after today, you'll see that as much as the cloud can sometimes have a reputation for being difficult or complicated, it can actually be fairly straightforward. And I'm going to show you the simplest, most direct ways to actually make use of the cloud. And by the end of this, whether you're following along, and trying to do it yourself, or just watching, and then you're going to click through the recording later with your project at the same time, so that you can pause and fast forward or reverse as you need to. Hopefully this will be a really nice resource for you to actually get started in our cloud. Just so that we're clear up front, there's nothing particularly impressive about the computer that I'm using here. It's a 2009 MacBook. I am going to run a version of VMware on this machine as well, so I can run a version of Windows 8. So you'll see how to connect to the cloud both from an Apple product and from a Windows product. So you should have a really nice project here. So users, if you haven't pressed mute yet, if you make sure that you are muted, apparently some people are receiving some feedback and that would be helpful. So please do that. So again, it is being recorded. I am going to move fairly quickly through this because I know it is being recorded, and we'll have it posted on our site within a day or two after this presentation. So if you find that you're falling behind, don't get too worried. You can log in a day or so, grab this, pause, and fast forward and rewind it as you need to. So I'll start with a quick overview of Compute Canada and the background policies around our cloud and what's available for it, and then we'll move straight into how to actually make use of the Compute Canada cloud resources. So, Compute Canada. Compute Canada is the national body that's focused on providing advanced research support for all the researchers. Historically, those researchers have been mostly from core science disciplines that use a lot of compute, things like particle physics, nanochemistry, bioinformatics. But Compute Canada is really expanding its reach and trying to grab more researchers than just those perhaps traditional high-performance computing researchers. So things like cloud are new and they're part of this, and they're a way to support research efforts from a broad variety of disciplines, whether it's human ecology or English or digital humanities or sociology or economics. So we have roughly 200 staff, and they're spread across the country at major research institutions with various foci. But you have the ability to interact with any of those staff. So if, for example, I'm at the University of Alberta, I'm the digital humanities specialist, but that doesn't mean that if you're at the University of Sherbrooke, for example, that we can't have a conversation, I can't help get you the resources that you need. It's important for everybody to know up front the content of this slide, and that's to understand generally what's available and to who. So Compute Canada has two different account types, generally, or most generally. So the first is going to be the PI account, so the Principal Investigator account. And these are available to faculty and librarians at pretty much any of the major research institutions across the country. So that's universities and colleges for the most part. But there are other institutes, for example, that have this access and this privilege as well. Principal investigators are able to sponsor other users, and they can sponsor anybody that it would be of use to their research to have access to resources as well. So most of the time this is graduate students, but it doesn't have to be graduate students. It can be people from the community, researchers from other countries, people from the community from other countries, graduate students from other countries. If they're doing work with you and you need them to have some compute power, some storage that they wouldn't normally have access to, you can sponsor them. There's two types of allocations. One is a default allocation, and you'll see here that this is available to both principal investigators and sponsored account users. So these are resources across all the Compute Canada systems that give you the opportunity to go in and set up some prototypes, some tests. If you only have some small work that you need to do, then the default allocation is often enough for people to get by. If it turns out that the default allocation isn't enough, then there are granted allocations, and this is handled each fall through a process called either the RAC, which stands for Resource Allocation Competition, or the RPP, the Research Portals and Platforms Competition. Both of these are granted allocation competitions, and they can provide terabytes, hundreds of compute hours, thousands of compute hours, tens of thousands of compute hours, etc., for the projects that you need. And there's any academic that's watching right now will be familiar with the whole peer review process that runs in the background to determine who gets what resources. The important difference between the default allocation and the granted allocation is the default allocation is available to sponsored users. So the sponsored users get a full clone of the principal investigator's default allocation. So it's not shared. So for example, if the principal investigator has 50 gigabytes on a system called OwnCloud that we run, which is like Dropbox, it's held here in Canada, has secure access and so on, the sponsored user will also get their own 50 gigabyte allocation there. And that's true for all the default allocations. Only the PI can have a granted allocation, but they can share that, so that's a shared resource with their sponsored users. So that's background for Compute Canada. Hopefully everybody's joined us now. So before we provide a little bit more background and then move into the actual workshop portion, I'm going to throw up four links here on a slide. If you don't have access to these already, here they are for you. And they should appear in the Etherpad too if you're following along. So the link at the top, ccdb.computecanada.ca, this is the interface for the Compute Canada user portal, right? This is the tool that's used within Compute Canada to manage allocations and storage, to tell you who you've sponsored and so on and so forth. The CCDB at the beginning of that stands for Compute Canada Database. If you go to that page now or in the future, you can just log in if you have an account already. If you don't, there's an option just at the bottom of the login to actually register and build yourself an account. If you have any problems during that process, that email, the second link here, accounts@computecanada.ca, just send an email there. Somebody from across the family that is Compute Canada will pick up that email, and they'll get you the help that you need to get the account that you're asking for. The web link, the third item on this page, I've shortened it. It's a link to the Etherpad page. So this is a bit.ly link, and that's just a tool that you can use to compress longer URLs. And so that's what I've done here. So if you don't have access to the Etherpad page already, here's a link for you to grab it right now. And it's bit.ly/1 lowercase p, capital N, capital E, lowercase d, lowercase w, capital K. If you can't log into that, or you'd rather just ask questions through this seminar, this workshop through email, you can just send an email to info@westgrid.ca. So I've mentioned before that Compute Canada is the national provider. Compute Canada has a relationship with 4 major consortia and all the sub-consortia that are within some of these major consortia. And you can see them here in the slides. So we have WestGrid, which runs from Manitoba to BC, Compute Ontario, Calcul Quebec, and AceNet. Going forward, and from the perspective of users, it should be the case that the experience for you is transparent. Whether you're within WestGrid, or you're within AceNet, or Calcul Quebec, or you just see yourself as a Compute Canada user, we're moving towards a single sign-on. So one password will get you access to the resources across any of these regions. You have access to almost all these resources now. There's a few that have very special granting allocation processes to get access to. But you have access. So you can be in Edmonton and you have access to the machines that are running in Calcul, Quebec, for example. Problem is right now we still don't have single sign-on, but that's coming. So you'll see a few hiccups today because of that. So let's talk about our cloud systems now. There are 2 major cloud systems and a whole group of smaller cloud systems that are running. So I'll pull out the two major cloud systems. They're Victoria and Sherbrooke, and I'll use the smaller cloud system here at the University of Alberta as just a representation of some of the other tools that are available. So Victoria and Sherbrooke are the primary cloud systems, and you can see just a snapshot of some of the resources that are available on them here. So we have roughly 200 terabytes of usable storage at Victoria, approximately 100 terabytes of usable storage at Sherbrooke, and this is after 3-time replication. So there's redundancy built into the cloud. So if a drive fails, we're able to remove it with no data loss, put in a new drive, and it gets rebuilt from the components of the data that were shared across all the other drives. And they're reasonably powerful systems. Victoria is about to see a major upgrade this summer, so we'll have a significant expansion in terms of what's available. We also have smaller clouds around the country. Most of them are held at universities and available just for the faculty and staff of that university. But there are some exceptions. One of them is here at the University of Alberta. It's a prototype cloud that we've put together off scavenged hardware. And it has roughly 150 terabytes of storage, depends on the replication we set up at the time. And we'll just use this to support researchers that aren't able to get more storage or direct access to some of the other clouds because they've already been allocated in the space that's there and that competition that happens every year in the fall. So there are other options that are available, but there's usually a trade-off. Victoria and Sherbrooke are very stable, right? And they're quite powerful. The Alberta cloud, it can be powerful, it can have lots of storage for you, but it's less stable because the hardware is being repurposed and it's currently out of support. But we can get you access if you want to get a leg up in terms of participating in the allocation competition in the fall. So that's background on our clouds. So let's talk particularly about this hardware and the software that are going to be running and what we're going to set up right now. So you should see a giant O on your screen right now, and that's for OpenStack. And OpenStack is the software package that makes it possible for Compute Canada to run its clouds. And it's the tool that's run on all the clouds, particularly the ones that I showed you earlier. So Victoria, Sherbrooke, and the University of Alberta, they all use OpenStack. This is a software package that has a number of pieces that connect together and plug in, and you can see that in the O on the screen. There's different layers, and you can see them kind of being built like Lego bricks. There's lots of terminology that's thrown around in OpenStack. So for example, the dashboard has a special name. It's called Horizon. There's different names for the console environments and so on. I'm just going to set all that aside, and we're just going to call things by the names you would usually call them. I point this out because if you're ever talking with somebody about OpenStack and they start mentioning a strange name, it's totally okay to just stop them and say, I'm new to OpenStack, I don't know the names of all the components, what are we talking about, and let them know. I'm not going to use any of that jargon here today. Important thing for you to know about OpenStack, and this is core for understanding the cloud environment that you're about to participate in, is the second point on this slide, and that's OpenStack provides infrastructure as a service. And so what this does, it provides you the ability through a software tool, through a browser interface, to pick and choose the hardware components and how you're going to assemble them, put an operating system on top, and it's really like building your own computer, except the physical computer isn't here, it's part of a shared system somewhere else in the world. Here, in this case, the systems will be here in Canada. So when you're using OpenStack, what you're really doing is building a computer that's going to sit somewhere else and do some work for you. And that's what infrastructure as a service means. You can get others that are platform as a service, and they'll come set up free with the operating system already loaded in certain ways for you. You can get software as a service. You may be familiar with this in Google and the Google Docs environment, where you actually get a document editor, so where you get a spreadsheet tool and you get that in the cloud. We're providing just the raw course tools here, and how you put them together is up to you. I mentioned before the default amounts or the default allocations that exist. And this is the default allocation that you get as a Compute Canada user in our OpenStack clouds. So you get the ability to create two what are called instances or virtual machines. So that's two kind of pretend or cloudy or however you want to frame it computers that are going to do some work for you. You get two public-facing IP addresses, and this is nice because you can actually address your web server or your virtual machine, and you can run a web server. You could host websites. You can transfer data around because it can be findable on the open web. You get 15 gigabytes of RAM. You get 4 what they call vCPUs. This would be the same as as far as you're concerned, as a CPU or a core. So this is the actual engine that's actually running the compute cycles. You get 40 gigabytes of permanent storage, which isn't a lot, but the reason we have these clouds are to run portals for research and to do websites and things like that to help assist you. So you need more storage than that. Of course, you can participate in the allocation competitions. You also get the ability to create 2 volumes, and these are basically the equivalent of USB drives that you're plugging into your virtual machine out in our cloud, and 2 snapshots. And so these are a way of backing up the computer. Imagine your computer at home and you had the ability to take a picture of the entire computer, its hardware configuration, all the software on it, and set it aside. So if your computer was lost or broken, you could just grab that picture and from the picture have it completely rebuilt. And that's what the snapshots allow us to do. So those are the core components of the default allocation. And when you apply for one of these, you'll get this on either Cloud East or on Cloud West. So I'm going to step out now of the presentation here with Keynote, and I'm going to move into some other tools so that we can access Cloud East and we can access Cloud West. So I notice here in the Etherpad there's a question about posting the slides. We definitely will post the slides. There's going to be a big section here where there's nothing that you're seeing from the slideshow because I'm doing it all live, but there are slides there that if you just had the slideshow you could follow along as well. So hopefully that's of use to people.
Another question on the Etherpad about whether the Alberta prototyping cloud is the same as their East and West clouds?
No, it's changing all the time. And the more hardware we can scavenge, the more powerful it becomes. And when things die, it's a bit of a Frankenstein machine. So if it's not fitting elsewhere, it's not working elsewhere, we're happy to talk to you. And again, ask your research institutions as well. For example, Calgary has a cloud for their researchers that they're putting together. Those are the 3 clouds that are currently being used broadly across the country by a variety of researchers. So we need to log in. So the interface for Cloud East and Cloud West are basically the same. So I'm going to log into both, and I'm going to create VMs in both. So you're going to see what I'm doing here twice. The reason I'm creating virtual machines in both is because I'm going to connect to one from Apple, from my Mac, and I'm going to connect to another from Windows, from the virtual machine that I'm running on my Mac right now. So you'll be able to see the process in both Apple and a Windows environment, right? Or Apple and a Microsoft environment. So if you've already got your credentials and you've logged in, then just follow along in the cloud that works for you. You won't be able to log into both clouds. So I'm going to log into Cloud East, and I'm going to log into Cloud West. There we go. So if you're just coming in, it might look like you've got a bunch of pie charts on it. That's where we're going to start. If it doesn't look like you have a bunch of pie charts, so my Cloud East case, for example, has a bunch of virtual machines that I've built listed here. If you click on the Overview tab here on the vertical bar on the left, it should be under Compute and under Project. It'll give you the same pie, the pie chart view. And that pie chart view lets you see very quickly what resources you have allocated to you and how many and how much of them have been used. So we can see for me and my Cloud East account, I've used up all my floating IPs, so I have no more connections to the outside world that I can make. And you'll also notice here that I have a little bit more storage and a few more instances than you have access to. And that's just because I'm running these demos all the time. When I'm done with them, I'm a good cloud community user, and I kill the things that I'm not using anymore. So after that, make sure that you can see those, right? So you can find the overview panel, and you can see it's different here in Cloud West for me because I have different things running. If we click on Instances, which is just under Overview on the left-hand panel, you'll get a list of all the instances. And what an instance is, it's one of these virtual machines. It's this computer that's running for you in the cloud. It's a space of resources or a collection of resources that have been carved off from a much larger machine and given to you. You shouldn't see any right now if you're logging in for the first time. If you do, well, somebody has made you a virtual machine, and I suppose you might want to be thankful for that. I have one here that I'm just going to delete quickly. I thought I'd already done that, but I apologize for not. And I can interact with it by just clicking on the left-hand side. So I'm going to get rid of this final 14.4 test. I'm going to terminate the instance. This is not something that you're going to be able to do right now. But what you will be able to do in just a moment on whichever cloud you're on is to actually create an instance. So if you can see up here in the top right-hand corner, it says it's scheduled determination, and then it just takes it away. Be warned, there is no coming back from this. You delete these things, they're gone. So it warns you up front. Do you really want to do this? And when you say yes, well, hopefully you really, really did. So whether you're on Cloud East or Cloud West, we're going to go through a launch instance. I'm going to go through it fully on one, and then I'm going to go back and do it faster on the other. So launch instance. I'm on Cloud East. So we get our launch instance panel here, and we see we have a number of different tabs. Some of them have stars beside them. Details, access and security, and networking have stars beside them. We care most about, right now, details and access and security. So we're going to fill in the details panel, then we're going to do access and security. We're going to skip networking until the VM is up, and then we'll attach our IP address. Availability zone, this is an option that's baked into OpenStack. We only have one availability zone. This is something that's useful for system administrators to control where things are running. As far as you're concerned, it's always going to be Nova, and that's the name that OpenStack gives for its default zone or default availability space. So really, it doesn't mean anything for you. We have to give our instance a name. And if you remember looking at my Cloud East account, I had named my previous one DH Twitter Scraper. Make sure it's something meaningful for you. My DH Twitter Scraper is scraping tweets for the digital humanities for some projects that we're running, particularly some training. So I'm just going to call this right now, I'm going to call it Junk 1. Right? You're welcome to have spaces here. This is only used in OpenStack. Underneath the instance name is a flavor. You'll see a whole collection of letters and numbers here. The first thing that's there is either a P or a C. And this is telling you, oh, a zoom in request. Can't zoom in. I'm just going to have to describe it as best as I can. I might be able to. Give me a second.
Control.
Yeah. I'm trying. Oh, there we go. Better? There's the zoom in. And I can't go much more or I won't have any screen space. I'm sorry. So flavors. First letter, P or C, this is telling you the type of processor that's there. So C is meant to be kind of a compute processor. There are tools that are able to come into the cloud and very quickly spin up a virtual machine, do some compute, and then shut themselves down. It's extremely resource intensive, and they're usually trying to basically melt those processing units. The P's stand for persistent, and these are intended to be used more often with web services, so a web browser, for example. Not a lot of research projects that are getting millions and millions of hits a day. So the processors that we use here are of a slightly different sort. The number that follows the C or the P, this is how many cores are part of that processor. So do we have 1 core, 2 cores, 6 cores? We have up to 16 cores for some, 32 cores for some of the compute ones here. The number that comes immediately after is the amount of RAM that's available. So we see here for the first one, we have 3/4 of a gigabyte of RAM. In the cases where there is a dash and then another number at the end, this is storage space that will be built directly into the virtual machine. It's sometimes called ephemeral storage or ephemeral disk. And what this means is that when the machine is built, that disk is built with it, and when the machine dies, that storage is lost as well. It works really well if you're running a quick compute job and then your machine tells you the answer and you don't need that data anymore. But if you're running a web service, for example, like a website or some online tools, you're going to want to keep that data around. So we are going to choose the most basic flavor right now. We're going to choose P1 with 3/4 of a gigabyte of RAM. We're only going to have one instance. We could put a larger number in here and create multiple instances at once. I need to choose a boot source. I'm going to choose to boot from an image and create a new volume. What this is going to do is it's going to find a picture, basically the equivalent of an old CD that would carry an operating system, for an operating system, and it's also going to create a separate storage device for us as well. So boot from image creates a new volume. The image that I'm going to use for this demo is going to be Ubuntu, or Ubuntu, right? So I have here under my select image menu, about in the midway down, I have an Ubuntu 14.04. And so this is the one I'm going to choose to run. We can see it has a footprint about 250 megs. Immediately under that is the device size. We're just making demo ones right now. Please don't be greedy with your gigabytes. You're not going to be, you might do something with this, but I imagine you're not. And for a successful Ubuntu launch, we need to have this root disk be at least 2 gigabytes. So I'm going to throw in 2 here for my device size. Device name, we could name it something special, but VDA is pretty standard within the Linux Unix environment. I'm going to leave that. The delete on terminate, we can link this equivalent to a USB drive to the VM in such a way that if I destroy the VM, the virtual machine, that it will destroy that disk as well, or not. For the purposes of this demo, I'm going to turn it on just so it makes it easier for me to clean up. Do not press launch yet, because we have an important thing to do, and that's come to access and security. Within access and security, what we need to do is select a key pair. You won't have one if this is your first time logging in. I can click here, I can see that I have 3 key pairs already, but I'm going to build a new one and show you how to do it. So I'm going to start by doing this on Apple, on the Mac environment, and then I'm going to come back and I'm going to do it for you in Windows, and it'll be exactly the same if you downloaded MOBA Xterm. So if I click on the little plus, it brings me up this little panel menu for importing a key pair. I see I need to give it a name, I need to give it a key, and on the right-hand side is a whole set of description on how to actually build that key pair and how to use it. So the description's there. It's available for you in our OpenStack installations. I'm going to now step back to my desktop and show you how to make this happen. So we're going to do Mac first, and then we're going to do Windows. Okay? We're going to do Mac and Cloud East, and we'll do Windows and Cloud West, and we'll do the second one a little faster. So for our Apple users, you're going to need to open your Finder, and if you go to Applications, down at the very bottom is a folder that you may not use all that often. It's called Utilities. If you open Utilities, at the very bottom there, you'll see that there is an application called Terminal. If you double-click on that, it will open Terminal for you. There's a faster way to get access to that, and that's to hold down your Command key and press the space bar. This will bring up the Spotlight search tool. If I start typing terminal, we can see that the application opens up, and if I press enter, it will run that application for me. Terminal is going to look like this. So you're going to see a command line prompt, and most of you aren't going to be used to seeing this sort of thing. So I'm going to run through how to actually build the key pair here. I'm not going to go into too many details about what's happening or other options that are available. This is something that you need to build up over time when you become comfortable with these Unix environments, or these Linux environments. So when you first log in, you'll be in your home directory, and we can see the contents of that directory by typing ls, right? So list structure, or list the structure of this directory. And we can see here I have various files and folders that are in there. And this is important for you to see up front because we're about to add 2 files to this. So ls will list the contents of that directory. I need to use a tool called SSH keygen. So it's SSH-keygen. And key is K-E-Y-G-E-N. What this tool is going to do is it's going to build us a key, actually a set of keys, a pair of keys that will use the secure shell environment, right? So these are secure shell, and that's what SSH stands for, keys. I need to tell it what type of key I want, and I do that by putting a space, a dash, and then a T. This says the next thing that comes is going to be the type of key, and I want to use an RSA key. This is a very common key type. It's pretty secure. And then the last thing I need to do is I need to give the key an identifier. I want to give it a name. So I'm going to tell it I want to give it a name with the -I command. And I want to call it cloud-east.key. Right? So SSH-keygen space -t space RSA space -I space cloud-east.key. And when I run this, it's going to be upset because I gave it, my mistake. I am sorry. So if you ran that and you got all that junk there, you can save yourself typing by just pressing up on your keyboard. And we're going to press back, and I need to replace the -I with the -f. I'm sorry, the -I is used when we actually connect. -f tells it the file name. So SSH-keygen -t RSA -f and then cloudkey.cloud-e. So when we run this, it's going to ask for a passphrase. So we can add a password to the key. So it's extremely secure. If somebody got the keys, they can't just open the doors. They also need to know the passphrase. So we strongly recommend that you use a passphrase with your keys so they can't be compromised. So please enter one now, but make sure it's something you can remember. Oh, and of course my passphrase is too short. So doing this so that you can see what happens and see these errors. Again, I can get back to where I was by pressing up on my keyboard. I don't need to type all that again. Press enter, and I'll make a longer passphrase this time. Still too short, and I used 4 characters. All right. Very good. So just keep throwing characters in there till what you get. You get kind of a random art image. It's intended to be like a fingerprint. So remember we used ls before to show us what was in this directory? If we do an ls again, now we see that we have additional files in the directory. We have a thing called cloud-east.key and a thing called cloud-east.key.pub. And that .pub stands for pub. This is a public key. So what we've done here is we now have a key to lock things and a key to open things. The public key will lock things for us. We share that with anybody that we want. and they can take content and they can encrypt it with the public key, and then the only key that can open it easily, ideally at all, is the private key, and that's the key that does not have any extension after key. So what we need to copy into our cloud key is the public key here. And so I'm going to type cat. It stands for concatenate, and this is a tool used on Linux systems to view the contents of files. And I want to see the content of cloud east.key.pub. And it will print out on your screen a long line of junk text. It looks like junk text, but this is really the key that will be used to encrypt our connections and keep everything secure. I'm going to use my mouse here. I'm going to highlight the content of this, and you can right-click and choose copy. You can also hold down Command and press C to copy this. You need to make sure you get the whole thing, right from just before the SSH-RSA, right to the end of whatever your username is. So for me, it's ist.ualberta.ca. We need all that content and everything between it. So I'm going to copy that. I'm using Command-C, but you can right-click and choose Copy. Now I'm going to hold down Alt and press Tab. I'm going to go back to my browser. I need to name my key pair. I'm just going to call this Cloud East Test. And in public key, I'm going to paste. I can right-click and paste. I can hold Command here on my Mac and press V and paste, or I can just pull down from the browser menu here and choose Paste. Sometimes when you paste your key, there will be an extra enter at the end. That's not okay. No more extra spaces, no extra characters or anything like that. So make sure you've got the key and nothing else. And once you've done that, we're going to import the key pair. It's getting upset because I can't have any spaces there. That's fine. I'll just take them out. I now have imported the key pair. It's selected here for me, and I can launch my virtual machine. So I'm going to choose Launch. And if all goes well, it should be the case that we get a success window up here at the top that says successfully launched the instance, and we'll see that it starts to build the instance here. We're not building something very large, so this should take less than a minute to actually set up. It's building an entire computer for you, so that's pretty fast. So while it's doing that, though, I'm going to switch back over to Cloud West, and I'm going to go through this process again, but faster. So if you've already done it, that's great. It's review. If you weren't able to follow along there, you get a second chance right now. This time I'm going to use Windows to actually build my key. So I'm going to click on Instances. We're going to see a list of instances here. You see I currently have one. It's called Windows Test. But I want to make a new instance. So I click on Launch Instance. Availability zone is Nova. There are no other options here. I'm going to give this a name. I'm going to call this Cloud West Test. You'll notice here that the flavors are a little bit different, but the principles are still the same. We still have persistent, we still have compute, we have the number of cores, we have the RAM that's available. So because we're just doing a demo here, I'm just going to build a small one so that we're not hogging resources that we're not actually going to use. I'm only going to make one instance, so my instance count is 1 here. I'm going to boot from image and create a new volume. The image that I'm going to use here is down at the very bottom. This is Ubuntu server. It's the same as the Ubuntu server that was on the other one. You can see there's a small difference here because the file size is slightly different, but in principle it's going to be the same for you. The device size, we need it to be at least 2 gigabytes to actually have success here. And we're going to leave our device name as VDA. And for this case, we're going to go delete on terminate just so we can clean things up really nicely. So, next thing, Access and Security tab. Just like we did before, You won't have a key pair here if this is new for you. You're going to make one by clicking the plus sign, and it's going to ask you for a key pair name and a public key. We need to build that public key on our computers. So let's go do that now. So what I'm doing here is I'm opening up a virtual machine on my Mac that's running Windows. So this will be the same for somebody who has a Windows 8 environment. So inside this Windows 8 environment, I've already installed MOBA Xterm. It's here on my desktop. Wherever you've installed it, you should run it. So I'm going to open MOBA Xterm. It's going to take a little bit of time. So what MOBA Xterm is it's going to provide basically a replica or a clone of a Linux environment here on Windows. So we'll get the same commands that make Linux a very, very powerful scientific and research computing operating system. And they'll be here for me in my Windows environment. I'm choosing MOBA Xterm over a bunch of the alternatives because it's just really clean and easy to use. So when it comes up, you may have a number of options that are floating around. You may have some extra menu items and so on. But what we really care about is there will be a panel that says Start Local Terminal. And when we start that local terminal, it's going to look very much like what you saw on my Mac, except we have a bunch more coloring. It's just some other formatting that's been built in. But we're going to do the same things in principle. I need to do an ls just so that we can see the contents of the directory, so you can see the change over time. We see there's much less here. There's a desktop, there's a launcher folder, there's a thing called My Documents. Now we need to build the key, and we do that with ssh-keygen-t for the type, and it's going to be an RSA key, and -f is going to be the file name, and here I'll call it cloudwest.key. When I run that, we see again that it's going to ask me for a passphrase. So I'm going to put one in that's longer than the 3 characters. I have to enter that passphrase again. When it's all done, we get another one of those fingerprints, and it's different from the previous one. And what I'm able to do now, if I type in ls, is see that we now have 2 files that we didn't see here before. And we can see that MOBA Xterm is being really helpful in coloring files differently from directories. I need to run a cat, C-A-T, it stands for concatenate. It's the Unix tool for displaying the contents of files for the public key. So cloudwest.key.pub. I'm going to copy this whole thing. So I'm just going to highlight that whole piece. I'm going to right-click, and I'm going to choose Copy. I'm then going to take that content, and I'm going to move back to my browser window. I'm going to give my key a name, Cloud West Test, and I know I can't have spaces this time. And I'm going to paste the key in here. And again, it's possible that you've picked up an enter or an extra space. That can't be there. We need to remove that from the public key. I'm going to say import key pair. It's now available for me, and I'm going to launch my instance. So going back here to Cloud East, right, we can see that I now have an instance that's up and running. I need to do 2 things before I can access it, and then we're done. I need to give it a public IP address, because if I don't have that address, it can only be found internal to the network it's currently on. And we want it to be found out there in the world. We want to be able to log into that, not just from our web browser, but from any machine that has that address and the appropriate credentials. So this is done pretty easily by clicking More. And at the very top of that menu will be an option for Associate Floating IP. This is what we're going to want to do. And it's going to give us an IP address, it will typically start with a 206. So I click Associate Floating IP. We get a new panel. I currently have an IP address available to me. If I didn't, I click the plus sign. There'd be a pool, and I would choose Allocate IP, and it would give me an IP address. I've already pulled all mine out of the pool, so that's why I can see an IP address here. So either choose an IP address if it's already available, or click the plus sign and choose to allocate one, and then you'll come back to this window and you'll be able to grab an IP.
Hi, John. I've just got a quick question that came through over email. It is, are there any plans to add any Hadoop and/or Spark functionality on the cloud?
I couldn't hear what functionality you were asking about.
Hadoop or Spark functionality?
Yes. So, for example, the university, we can run Hadoop and Spark in the regular cloud. Here at the University of Alberta, in that prototype cloud, we have it baked into our instance of OpenStack, so it's a little easier for us to run that. But it's coming in various ways to the cloud. So can it run now? Yes. It takes a little bit of technical competence to pull off, but it's totally available. And over the next year, we're going to make this much more accessible for people. I'm not going to demonstrate any Hadoop or Spark functionality right now. I apologize. We're just going to start a basic VM.
Oh, that sounds good. But just noting time, there's about 10 minutes left, just so you know.
We are almost done, believe it or not.
Great.
Yeah.
Mm-hmm.
So with questions, I might be a minute or two over, but we're very close to being finished. So we now have an IP address, right? And this is available to us. The next thing that I need to do, because I can find this on the web, is I need to come to Access and Security. That's on the left-hand panel menu here. And there's a security group that we've been ignoring so far, and it's called the default group. And you can create multiple groups, but our VM, our virtual machine, is already part of the default security group. And what we need to do is manage rules, because the default situation is we've given you a firewall that's going to lock out pretty much everything. We need to be able to SSH into our virtual machine. So if you'll notice here on my screen, I already have a rule here for ingress. This is for incoming connections. And under port range, it's port 22, and in brackets we can see SSH. That's because I've already set this up, because I already have some virtual machines running here. You can easily add this by going Add Rule in the top right-hand corner. Under the Rule menu, if you click there, there'll be a whole lot of options. These are all the basic connecting options that most virtual machines might need. So you just choose SSH from there. It'll fill in a whole bunch of other details. Here it's only 2, so it'll tell you what's remote and a bunch of 0 numbers. These don't matter. Just leave them as the defaults and choose Add. I'm just going to choose Cancel because I already have it, but you need to choose Add. So once you've done that, we're on Cloud East. So we're going to come back to our terminal. So this is my Apple users. We're about to do the Windows terminal, and then you're good to go. So I'm now going to create a connection from my Mac machine to that machine in the cloud. And I'm going to do this as follows. I'm going to say SSH. Now here I need the -I. I need to know my identifier. And so here is where I'm going to use not the public key, but the private key. And so here, my private key, SSH-I, for Cloud East, I called it cloud, capital E, and then east.key. So that's the identifier. That's my credentials. That's what's going to open the door for me. And I'm going to use, where am I going to go? I'm going to go to Ubuntu. Ubuntu's default username is Ubuntu. When we made that virtual machine, it created a username called Ubuntu. And when we gave it that key, the public key, it associated that with the username Ubuntu. And we now need our IP address. Oh, well, I don't know what that is. So I'm going to go back. I'm going to come back here to my browser. I'm going to go back to instances. And underneath here, in my junk test, I have an IP address. I could memorize it. I'm just going to copy it. I'm just going to highlight it, and I'm going to use one of my copy tools to take that and then dump it in the bottom here. So the command is ssh-i, the name of your key, and then your username at the IP address or the server that you're trying to connect to. When we run that, it's going to ask us, do you trust this? Is this really where you want to go? We're going to say yes here. We have to type yes in. It's going to add it to something called the list of known hosts. You will be asked for a password if you put one in. So I put my password in. I say OK. It's going to add it. And welcome to your virtual machine. And it's going to be a command line virtual machine. So something that would be really good to do would be a bunch of updates on this, but we'll set that aside for right now, and we'll move on. I know, we'll be done in 5. So there's how to do it on one. We'll do it much quicker on the other, and we'll be done. Then it'll take just probably 2 minutes past the hour to show you how to do it on Windows, or maybe we'll just set that aside for now. It's probably the thing to do, given the time. But it's even more straightforward once we set up a virtual machine for you in Windows. So to see that again quickly, the second time on Cloud West, and this time I'll use Windows and MOBA Xterm to connect. I now have my Cloud West test available on my instances panel. I need to associate that floating IP. It says no IP address is available here. So this is the case that I mentioned might happen before. I'm going to click the plus sign. Apparently I only get one IP here. That's a problem. So just to make sure this works, I'm going to have to come back here. I'm going to have to disassociate this floating IP. And then I'll reassociate it. With the VM that I just created. We see here now that it's moved to this new VM. I don't need this Windows test one. I'll delete it later. I'm going to copy the IP address from here, and now I'm moving back to MOBA Xterm on my Windows virtual machine. I'm going to use the same command, right? SSH-I for my identifier, and I'm going to go to cloud west.key. This is the full key, not the public one, right? This is the one that unlocks things. And where am I going to go? I want to take that. I want to go to Ubuntu at, and now I'm going to paste that IP address. And I'm going to run that command. We're going to see the same, should see, yep, permanently added the key to the list of known hosts, so it's made its connection. It wants the passphrase. Here I type it directly into the browser. Sorry, directly into the terminal window. And it's taking its time. I imagine there's a number of you that are trying to do this at the same time, and if there's a few hundred of us, it's going to take a while to actually connect. So, in the interest of time, it will connect. Here it goes, right? So it's really nice. And I can do things like type the ls command that we used before, and we can see that there's nothing in the directories that I'm in right now. And so now you've made all your connections, and you're good to go. So that's all it takes to open the OpenStack dashboard, create a virtual machine, build yourself a key, associate a floating IP, change the security rules, and then log into this VM. Now I recognize that for many of you, an environment that looks like this command line isn't something that you're comfortable with, but this is something that researchers in the core sciences that are using these tools have become very comfortable with over time. Researchers in other disciplines, like the humanities, for example, they are starting to become very comfortable here as well. We also have graphic user environments that you can set up to run here. It's less good for Linux, but the Windows ones are really fantastic. We're basically out of time, so I'm going to return to the slideshow. Return to the slideshow here and just really wrap up and conclude for you. So,
if you have time for one more question, another one through email, someone is asking if you can perform GPU computing on the cloud platform.
Graphic processor units. Currently, the clouds do not have graphics processing units associated with them. However, what you can do currently is you can run your cloud environment and you could use that environment to send jobs as a batch processed job to the graphics processing units. Graphics processors are the most oversubscribed resource we currently have. I think the last allocation competition, it was something like 3 to 4 times the number of requests or computer core hours than we actually have available. They're a major part of the CompuCanada upgrades that are happening over the next year. Whether or not they plug directly into the cloud, that I'm not sure about. So, quickly wrap up. We've got 2 slides and then we're done. We've talked about OpenStack. It's the cloud proper. It's what gives you the ability to build basically a small version of a personal computer somewhere else on the internet. Maybe many of those, maybe a very large personal computer, and have access to it and run it as a web service or any other tool that you would like. There's 2 others that are important. One of them is OwnCloud. Most of you listening today probably have Dropbox. You probably only have a few gigabytes in Dropbox. CompuCanada provides an OwnCloud service. This is a kind of a Dropbox clone. We'll give as a default allocation, this is to any CompuCanada user, 50 gigabytes of Dropbox-like storage, which is pretty nice. It has some really nice security features built into it, particularly the ability to turn off after a certain period of time links. So if you share links to files, you can say after April 1st they're closed. You can add passwords to them too. The other really nice tool is Globus. It's a file transfer tool at its core, but what it really allows you to do is access files and data across multiple systems securely and control them all from a web browser. So you can be traveling, doing your research, you can access your desktop at home, wherever that may be, and transfer files to somewhere in the middle of the United States, even though you're currently traveling in China. So that's another service that CompuCanada offers as well. It's cloud related. This is our last slide. So just to recap and to give you one new piece of information. If you need a CompuCanada account, you go to CCDB, stands for CompuCanada Database.compucanada.ca. Follow the registration components that are on that page, and the links should take care of you. If you have any trouble doing that, you can send questions to accounts@compucanada.ca. One of the experts across the country, usually one from your region, but it could be from anywhere, will give you a hand and sort out the challenges that you're having, particularly if you're worried about account types and things like that. Cloud@compucanada.ca is another email address that's available to you. If you have questions specifically about the cloud, what's available? Can I get GPUs? What's coming in at the University of Victoria? How do I do cloud bursting? Is it possible? What, so, where, how, when? These sorts of questions. That's a great place to send your questions. The cloud team from across the country will pick those up and they'll get you answers. Small caveat on that, there are supposed to be at least 250 of you watching today. If it takes them an extra day or two, I'd say a few hours, but they're not quite that fast, to get back to you over the next week, please cut them a little bit of slack. The very last piece is spark@compucanada.ca. CompuCanada is responsible for running Spark, and that's an acronym for Sustainable No, my mind has lost me. I don't remember what the P is for. Advanced Research Computing. Sustainable Planning for Advanced Research Computing, which is the group that looks to create the plan and then enact that plan for how high performance and advanced research computing should be laid out, supported across the country. If you have any thoughts about this, please send an email to spark@computecanada.ca so that we're able to hear from other users. In particular, if you're a Windows user and you have not been using high-performance computing resources because mostly it's done in Unix or Linux, send an email to spark@computecanada.ca, tell them your Windows computing needs, because the cloud is the place that stands to be the game changer here. Because we don't have to provision an entire system with thousands of cores and force it to run one operating system. It's really easy for us to spin up Windows machines. The challenge is the Windows licensing, and if we're going to overcome that, we need to know it's important to you. So that's all I have to say. Hopefully this has been useful. We'll hang around for questions, but if you have to go, that's my hour less the 5 minutes that Janet took for her intro. So I think I'm good. 60 minutes. We're done. Thank you.
Thanks very much, John. Definitely, if people do have questions who are connected via video, you can unmute and ask them now or continue to type them in the group chat. If anyone is still watching via the web stream, you can still post questions to the Etherpad and or email them to info@westgrid.ca. And I do have one question via email that, John, if you have time to answer.
Yeah,
you had mentioned.
I have time right now. We're good. So I can stay around. We've done the demo. It's now question time. So anybody that wants to hang out, I'm here. We've got the rest of the team too.
Great. So I've got a question via email, and they say that you had mentioned earlier the need to run updates on the machines after they are created. How fresh are the images for new instances, and which are the freshest?
So why don't I do two things right now? One, I'll answer that question, but I'll also show actually how to do the basic updates on these core machines. Okay? So the updates, in terms of how fresh they are, so if we come back, and so here I'm in Cloud West. If I was to make a new instance, not the flavor that matters, but if I choose boot from image, now I get to see all the images. You'll see that there is a core version number associated with each of these images. So they are just that core image. So the Ubuntu server that we started is 14.04. That's just 14.04. They've already moved on to 15, and they may have gone past that as well in some of the development environments. We're running 14.04 because it's a stable environment. So you know exactly what you're installing, and it is exactly the number that's listed there. If you want to do the updates, that's going to depend on the particular operating system that you're using. So I'll show you how to do it for Ubuntu. It'll be exactly the same in either machine, right? So I'm just going to use, well here, let's do it in the Windows one here. No, it's being slow. So we'll do it in the terminal. I'll do it in my Apple machine on Cloud East. Cloud West? Cloud East. So it's pretty straightforward to do in Ubuntu. It's just a set of 3 commands. So the first one is going to be sudo, right? And sudo stands for super user do. Linux systems have built into them 2 different core account types. There's a regular user that can just use the system, and then there's what's sometimes called the super user or the root user. And so when I say super user do, I'm saying as the more powerful, the administrator, do the following command. And that command is going to be apt-get. And so apt-get or aptitude-get is the tool used in Ubuntu for updating all its packages. And what I want to do is first I want to update. And so update is going to, so sudo space apt-get space update. And this is going to pull down all the new definitions that exist for this particular software, this particular operating system. And here it's Ubuntu 14.04. And we can see it going out there and grabbing tons of content. So it'll run this in the background. And when it's done doing that, I'm then going to run a sudo space apt-get upgrade. So what we've done is we've pulled down all the content, all the new definitions, and I'm going to go apt-get. Instead of update, I now actually want to perform an upgrade based on the new definitions I pulled down. It might ask you, do you want to do something, yes or no, here and there. I'm going to say yes to this because, of course, I want to do the update. And it will run through and it will perform all those updates. The very first time you do this, it might take a little while because there might be a lot of updates. But after that, you can do it every week or so and you can navigate that. Is that good? I should point out something else for anybody that's still hanging out, and that's please delete your virtual machines if you're not using them. So this Cloud West one, I'm going to put a check mark in the box and I'm just going to terminate it. And the reason is if we're not using the virtual machines, it may be the case that somebody else could, for a short period of time, make use of it. So let's play friendly in the sandbox and put our toys away when we're done with them.
Thanks, John. So I have one more question via email. The question is, would this cloud account support installing a private instance of Galaxy for Windows users? And if so, how complicated would this be?
I don't know. I don't know anything about Galaxy. I'll tell you who would be a great place to give you an answer, and that's cloud@computcanada.ca. Unless Mark is kicking around in the video window in the background and has a fast answer for this, that's more than I know. I don't have the experience with Galaxy, I'm sorry.
No problem. Mark, I don't know if you want to jump on, or I'll just forward that email to you. Oh.
Hello. Send an email to cloud@ComputeCanada and we'll forward you to the correct person. I personally don't know Galaxy much, but some people in Compute Canada knows about it, so we can forward you to the right person.
It's probably a good point to just underscore the importance of the network of experts that we have across the country. Right? It's very easy within your small research group to get caught up and not have an answer to a question, even if you're not using some of the Compute Canada services, but you need advice in terms of running your systems and getting your research done, and it's some advanced research computing tool or practice or method, you can send questions to things like cloud@ComputeCanada.ca and just say, what's even possible here? We're experts here to help you get your research done, not just to make the machines run so that you can go do your own thing. We want to support you in all the ways we can, and if that's giving you information, connecting you to an expert somewhere else in the country you didn't even know existed, we're happy to do that too.
John, I also just typed in something in the group chat. I'm not sure if you're able to see it. This was a request for help. When a user tried to create their key, they got an error message. And so I'm not sure if you can see that.
That escape character. Yeah, that's weird. So I'm adding that to the very bottom of the Etherpad page here. Sorry, I'm going to try and make my Etherpad page bigger so that people can see it. That escape character. So here's the issue. They put a space between SSH and the dash for keygen. So it's actually connecting, it's trying to run a command called SSH, which is what we use to actually connect to the outside world. And it's not recognizing dash keygen as an option because it needs to be brought together, so it's a single command. So at the bottom here, Vineet has added in on line 165, somebody's added in, I thought it was Vineet, Somebody with lighter text than me has added in SSH-keygen needs to be lowercase without spaces. So the full command here that this person would need to use, keygen-t rsa-f cloud east.key, right? Would be the correct syntax for that. And that's the command line being very, very particular. And it's one of the things that people find frustrating about the command line. And it's a trade-off for the kind of power that the command line gives you over just pointing and clicking all the time. Because then that power comes from the ability to be very, very specific and the ability to do things over and over and over again very, very quickly. So hopefully that helps them. Somebody's filling in the tab completion. So tab completion, for anybody that's looking at the Etherpad at the bottom, this is an option to, as you're typing a command, press tab and it will try and complete that command for you, so you don't have to type the whole thing if it's long and you're not at risk of making mistakes. And I'll show you what that looks like really quickly right now. Oh, when you're actually doing your update, you may see a menu like this, and we'll just keep the local version currently installed. And let's go to, come here. I'll come to my Windows VM and MOBA Xterm, but it'll be the same in my Apple machine. So if I'm going to do SSH, just being unresponsive right now, I don't know why. I'll make a new terminal window and we'll solve this problem. So here's a new terminal window. If I do SSH-key, but I only put in SSH-K and press tab, it will immediately jump to key. If I press tab again, it will show me that I've got two options. I can have a key scan or a key gen. So if I put the G in and press tab, it will complete it and I get the key gen command. It's a nice little helpful tool, the same as pressing up and down is very helpful for not having to type things again. Anything else?
There are a few other questions coming in via email, but I think what I'll do is forward those to you and Mark perhaps directly, and then they're getting a little more involved questions now. So
they are getting a little more involved. So we can. I'm happy to stay around and answer them.
It's just people watching by the web browser don't have time to speak to them, and it might just be easier to put you directly in touch with them than me being the messenger.
Sure. So you don't have to be the messenger. If they send emails, we'll deal with them after the fact. If people are still in Etherpad, then we'll clean them up right now.
Yes, definitely. So I guess one last call out to anyone who wants to speak up via video. Please pose a question now if you'd like. Otherwise, we will end this call, and otherwise John and the rest of the team will be available to answer questions via Etherpad. I'll be forwarding any other emails that are sent through to info@westgrid.ca, and they can also attend to those. But thanks, everyone. Thank you very much, John, for the presentation today.